Okay, so now we want to discuss the natural frequency of a pendulum and a spring. So in our previous segment, we talked about how to calculate the spring constant of a spring. So the spring constant was the letter C, and it was going to be how stiff the spring was. And so the whole purpose of the previous segment was to be able to calculate the spring constant, so then we can calculate what the frequency of a spring is. Now you'll notice I didn't put down any of those equations for how to calculate the spring constant because that's not going to be on the lecture exam. It is, however, going to be in lab, and you will have a chance to use those formulas in lab to calculate the spring constant. So I'm going to give you the spring constant on the exam. You have to be able to put it into this formula in order to calculate the frequency of a spring. So here we're going to have a spring, and then here is a mass that is suspended from it. Now we're going to take the mass and we're going to pull it down a little bit, and we're going to let it go, and it's going to oscillate up and down with a certain frequency. And so that the frequency of a spring is going to be given by 1 over 2 pi, where pi is a constant which is equal to 3.14 to 3 significant figures. Now it's actually much longer, it's infinite in length as far as we know, but for purposes of the exam you only need to know it to 3 significant figures, so 3.14. So that's going to be what that thing is. And then you've got the square root of the spring constant, and then divided by the mass that you're putting on there. So that's the formula. Now on the exam, you need to be able to answer 2 kinds of questions. One is a conceptual type question that really doesn't involve too much mathematics. And then the second kind of question is a math problem. So let's start with the conceptual question. So we said that we have this mass M. We're going to pull it down, let it go, and it's going to oscillate with a certain frequency. Now what would happen if I took a larger mass and hung it from the same spring, and I pull it down and I let it go? Is it going to oscillate at a higher frequency? Is it going to oscillate at a lower frequency? Or is it going to oscillate at the same frequency that it did before? So you should be able to figure out the answer to that just by looking at the equation. All right, now use this to guide your thinking, that 1 divided by 10 is equal to 0.1. And then 1 divided by 100 is 0.01. So notice that the bigger the number that you put in the bottom part of a fraction, denominator, so this is the numerator on the top, denominator on the bottom, D for down, D for denominator, so that as this number gets bigger, this number gets smaller. So if I used a larger mass, and mass is in the bottom part of this fraction, then what will come out will get smaller. So what would that look like? So if it was doing this, and when we put on the larger mass, the frequency will go down. The frequency is going to be the number of times it goes up and down per second. So if it goes down, then that means it's going to be doing it slower. All right, answer this question. What would happen if I have a rubber band that has a certain mass M on it, and then I got a shock absorber that has a certain mass M on it? So they both have the same M. What's different this time? This time it will be the spring constant. The spring constant is the stiffness of the spring. So that the rubber band is not very stiff, so it has a small C value. The shock absorber is stiff. It has a very large C value. So what would happen if you have a large C and it's in the numerator? It's in the top part of the fraction. Well, then what comes out gets very large. So that, what would that look like? You put the shock absorber on there, you pull it down, you let it go, and it's going to do this. It's going to have a very high frequency. Now, let's do it mathematically. Okay, so here is another kind of question that I could give you. A spring has a spring constant of 100 newtons per meter. A 50-gram mass is hung from it. At what frequency will it vibrate at? So write down what you're given and what you're looking for. So we're given the spring constant. Don't worry about the units on there, but it would be in newtons per meter. The mass is 50 grams, but that's the wrong unit. It has to be official metric units. So divide by 1,000, so it's in kilograms. And then we're looking for the frequency. So the next step is to find the formula that connects the letters. So that's going to be this one here. We're going to put in our numbers. Now, it's incredibly important that you use the correct order of operations with your calculator. Do not try to do it all at once on your calculator. Okay, break it up into bite-sized pieces. So, for example, the first thing that I would do on my calculator is 2 times 3.14. So if I take 2 times 3.14, I'm going to get 6.28. Okay, and I'm going to write that down on my piece of paper. Okay, then the next thing is I need to take 100 divided by 0.05. Okay, and so that's going to turn out to be 2,000. So on my piece of paper, I'm going to write 2,000, but I need to take the square root of that. Okay, and then over here, remember that this is 1 divided by that. 1 divided by 2 times pi. So I'm going to do this piece next. 1 divided by 6.28. And so that's where the 0.159 is coming from. Finally, I'm going to take that number and, well, I need to take the square root of 2,000 and then take that number and multiply it by the 0.159. And so that's where the 7.12 comes from. Please, please, I'm begging you, do this one at home with your calculator and verify that that is the correct answer. And if it's not, send me an email saying that I need to redo that question there. But I think it's correct. So you see how many different steps are involved in doing that. Now, the faster you get, the more shortcuts that you can take in using your calculator. But for right now, you can see that there was a lot of different places to make a mistake on there. And so if you're not doing the correct order of operations, you're not going to get the correct answer. So the number is 7.12, and then the official metric unit for frequency is going to be the hertz. So stick the HZ on the end of it. Okay, let's take a break, and when we come back, we are going to discuss what would be the formula for the frequency of a pendulum.